Hello Legacy students, Marsh here. So today we're going to look at graphing square and cube roots. You're going to want the graph paper, some graph paper, notes, those two papers I gave you in class, pen or a pencil, and then also a calculator as well. Now, let's do some review of general shapes that we've talked about that are connected to square and cube roots. If you remember, x to the third, that was a graph that looked something like this, right? And then x squared, those are parabolas. They look something like this. Well, that's a really bad parabola. But nevertheless, parabolas, right? Now, since we're going to be looking at cube roots and square roots today, what is going to happen is these graphs are basically just going to be turned to the right, kind of, in that regard. They're going to look very, very similar to these ones that we have. Now, grab out your parent square root paper that I gave you in class. So square root function is going to look something like the square root of x. Let's first fill out some information about it. So we're going to fill out our table here. So the square root of -1, right? So if I plug in -1, well, that's going to be an I, right? So there is no answer for that. NA, X, whatever you want to write there. I'm going to write NA. So it's not applicable. 0, if I plug in 0, square root of 0, well, that's just 0. Square root of 1, 1. Square root of 4, 2. So I can't graph -1 NA. That's not an option. 0, 0. 1, 1, and 4, 2. So it's a graph that looks something like this. Notice, guys, it's not going to the left because we don't have any values for -1. No x values can be negative. If they're negative under a square root, then it doesn't work. So we have to keep all to the right side of it. Notice our x-intercept is 0, 0, and so is our y-intercept. Domain, notice we're starting at an x value and we're going to touch it, so we get a bracket there. So 0 to infinity for our domain. Range, same thing, 0 to infinity. We are continuous, no open dots or holes in here. Remember, even was folded along the y-axis, definitely not the case. Odd was diagonals matched, definitely not the case. So this one's a neither. Notice, guys, the maximum on this graph, it's going to keep growing up. So we would say that the maximum would be infinity. It's going to keep going up. Minimum, however, would be at y equals 0, right? Or the point 0, 0 would be another way to write that your minimum would be at 0, 0. That's the lowest my graph can get. Intervals of increasing, it looks like from left to right, looks like I'm only increasing. So from 0 I start to infinity, none for my decrease. So as x goes to 0, so as I get closer to 0, f of x is getting closer to, well, if I get closer to 0 on both sides, that means I'm going to 0, right? Now, as x goes to infinity, I'm also going to go to infinity. So what we're going to want to make sure we know is this root table right here. The parent table is going to be the biggest important thing of this unit. So let's try to do a graph of a square root using our parent table. So first of all, I'm going to write down my parent table. -1, 0, 1, and 4. And then remember, there was no value here in that regard. Then I had 0, 1, and 2. So then I'm going to think here. How did this graph become what it is? Well, I went right 3 and then up 4, right? Because remember, if it's a negative on the inside, that makes you move opposite of what you thought and then up 4. So then, just like when we were graphing our quadratics, we're going to go right 3, so I'm going to add 3 to each of these. and up 4 to each of these. Since this one is, I'm going to redo that. -1 doesn't work in there. Never will be. Why am I doing those? Start here. So let's try making a graph and a table. So let's first start with our parent table. Now we're not going to do that whole -1 thing because that's going to be an A, right? So let's start with the starting graph. So 0, 0, 1, 1, and 4, 2. Now I gotta look at my graph here. What's going on? Well, it looks like we're going right 3 and up 4, right? Because remember, inside the radical made you go backwards from what you thought it normally would. So if it says a negative, it meant it went right, and then up 4 on the outside. So I'm going to fix my table to match that. So I got to go right 3. Okay, I got to add 3 to my x values, and I got to add 4 to my y values. So that looks like my table will be 3, 4, x, y, 4, 5, and 7, 6. Looks like. So let's graph those. 3, 4, 4, 5, and 7, 6. Whoa. Can't draw today, it seems. My problem is... There we go. So that is my square root graph here. Now notice, guys, my domain don't have any x values after 3. So my domain would be from 3 to infinity. My range, however, would be from 4 to infinity. There we go. Let's try another one. So now I have a -1/2 square root of x plus 2 minus 1. So I need to first lay down my parent graph here, my parent table. Now I gotta figure out what's all going on. Well, it looks like we're reflecting, right? From there. I also am compressing. I have left 2, and I'm also down 1, it looks like. So first thing I'm going to do is I'm going to take care of my left. So I'm going to subtract 2 from all my x values. Reflect's is going to change all of my y's signs. It's going to make them negative, because if I'm reflecting in the x-axis, my y's are what's changing. And then I need to multiply by my compression, so multiply by the half, because that's affecting the y values. And then ultimately I got to go down 1 as well. So let's figure out our new table. 0 minus 2, -2. 1 minus 2 is -1. 4 minus 2 is 2. Alright, so 0 times a half minus 1. That looks like it's -1. -1 times a half, it's -1/2, minus 1 would be -1/2, looks like. 2, or -2 times a half, that's -1 minus 1, -2. Oh, I messed up. Because -1 times a half, that's -1/2. And then I subtract 1, that's -1.5. My bad. So -2, -1, -1, -1.5. And then 2... Went the wrong way. -1, -1.5. And then 2, -2. There we go. So my domain, it looks like it's from -2 to infinity. But my range, notice guys, since this guy's a flipped, it's -infinity to -1, including -1. Well, now let's try a look at the parent cube root graph. So cube root graph looks something like this. Let's plug into my table here. So cube root of -1, that is in fact -1. Cube root of x, or cube root of 0, be 0. Cube root of 1, 1. Cube root of 8, 2. So I'm going to graph those dots here. -1, -1, 0, 0, 1, 1, and 8, 2. Then also another dot on here. -8, -2 would be also. So notice, guys, it kind of like an S, if you want to call it that. My domain, -infinity to infinity. Range, I get all of the y values too. I'm continuous, it looks like. Ooh, this one's an odd function. Notice no maximums and minimums, so my maximum would go to infinity. My minimum would be -infinity. That's how far down I go. Intervals of increasing. Well, it looks like I'm increasing the entire time, right? Left to right, keep going up. I never decrease. So as I go to -infinity, it looks like my y values are going to -infinity. And as I go up to infinity, I'm going to infinity as well. Main thing, x-intercept 0, 0, y-intercept 0, 0. Main thing, again, we're going to want to remember this parent table right there. So let's try graphing again. So let's fill out our parent table here. 0, 1, and 8. So this is -1, 0, 1, and 2. So I know that I'm going right 2 and up 1. So I got to change my table to reflect that. So right 2, up 1. Okay, so it looks like I got -1 plus 2. That's 1, 2, 3, and 10. 0, 1, 2, and 3. Looks like that's my graph. So I got 1, 0 right here, 2, 1, 3, 2, and 10, 3. Doing something like that. Notice it's always going to be an S shape. It's never going to end because the negative x values don't affect a cube root. So my domain, it looks like I got all of the x values, and it looks like I'm going to get all of the y values as well. Let's try the next one. We'll see if that happens again. Okay, start with our parent table. 1, it looks like we got a reflection going on. And we're also going left 5. So I gotta subtract 5 from all my x's. And then it looks like I gotta change the signs of all these guys. So that's gonna be a positive one, negative, and a negative. So my new table is gonna be -6, -5, -4, and 3. 1, 0, -1, -2. So let's see how this flips my graph around. -6, 1, -5, 0, -4, -1, and 3, -2. So it's going to look like a graph that's going to do something like that. Oh, whoa. I really messed up there. Let's fix that. Okay, -6, 1, -5, 0, -4, -1, and 3, -2. It just didn't look right. There we go. Because you should always have that one point that goes all the way out. There we go. So that should be my graph. Notice, guys, it is a flipped compared to what it normally does. Normally the S would look like that. It's like a flipped S, if you want to consider it that way. My domain, again, is negative infinity to infinity, and so is the range. And I'm going to give you a secret, guys. All cube root graphs will have that for their domain and their range. And that's the end of the video. See you later, Sabers.